This video will focus primarily on the window where your image has been drawn. You'll see the small chevron that we call the turtle. It just so happens we changed it to the turtle shape, but it will start off in the center of the screen or window. Specifically, your screen is really set up in 4 parts or quadrant, and of course it represents the Cartesian coordinate. It is laid out as a Cartesian coordinate where the horizontal line is the x-axis, the vertical line is the y-axis. The center is 0, 0, so x is 0 and y is 0. So looking at one of our demonstrations where we design a square, at line 17 you'll see turtle dot forward 200. It starts at the center and it's going to move forward 200 pixels. Next, at line 18, it says turtle dot right 90. And so it's going to do a 90-degree turn. And with this 90-degree turn, it's going to move downward. So we'll go downward here from where the 90-degree angle is. That 90 degrees is relative. So the angle is always going to be relative when it comes to the position itself. So it moves downward 200 pixels. And then that's what happened at line 19. At line 20, it's going to do a right degree turn again. So after it turns right and it draws another line, go forward 200 pixels. At line 19, at line 20, you'll see the right 90 degrees. So as soon as it does that 90 degree relative to where your chevron is or your pointer, then it is going to draw another 200 pixels. So thus far we've gone turtle forward at 17, 200 pixels, right. Line 18, that was the right 90 degrees. And then at line 19, turtle forward 200 pixels again. And then turtle dot right 90. And then at line 21, we're down now at line 21, turtle dot forward 200 pixels. And then at line 22, we're going to do a right 90. And then the last step for drawing the square would be turtle forward 200 again. Okay, so you kind of have a better idea, hopefully a better notion of how everything happens. Forward 200, 90-degree turn, forward 200, 90-degree turn, forward 200, 90-degree turn, and then forward 200. And that essentially draws your square. Obviously, the computer is a little bit more accurate, and the approximation is a little bit better on the computer screen. So let's run the program as we see it on the screen. And I removed any of the colors right now because I want to just show the actual square. So when you run the program, and I'm going to slow it down just a little bit by using a special function called speed. Okay, let's run the program so that you can see the drawing on the screen. And as you can see, it moved it started in the center of the screen, and then it moved east, 90-degree angle, moved downward, 90-degree angle from relative to where the pointer is located, and then it created another line and then moved 90 degrees and moved upward. And that's how you've got your square. Remember, when you're using the right angle, you're more or less looking at a relative change. Thus, when you use the right degrees, it's going to turn the direction that that turtle is facing right. It's always going to go clockwise and the 90 degrees, and that's why it went downward. And then when you indicate right angle 90 degrees again, clockwise, and then we do the 200 pixel drawing, clockwise 90 degrees, and then the 200 pixels drawing. What we need to emphasize is that when you use the angles, it's always going to base it relative to where the cursor is located. Later on, we're going to use something called set. The heading, that sets the orientation of the turtle, and that's more of an absolute positioning versus a relative position. Adding an angle or a degree to this program So turtle speed 1 is going to slow down the speed of the image as it's being drawn. So let's run it and you'll see. So it changed to the angle to a -45. It changed the direction slightly, offset it, and it ends up looking like a diamond shape. And so this is what the screen is going to look like, and it resembles closely the actual drawing using Python. Suppose we wanted to take this diamond shape and move it in a different location. To go about that, there is a command that allows us to move this shape in any of the 4 quadrants. But just remember, like mathematics, when you move over to the right horizontally, that's in the positive direction. The left is negative. And if you were to move upward, vertically rather, that is going to be positive y axis, and moving downward would be negative axis. For example, suppose you wanted to take this diamond and move it in this quadrant. That means up the y-axis vertically and to the left, the x-axis. Then here's what we're going to do. Okay, so what we're going to do is we're going to use the pin up, or you can just say up, turtle.up. And then that's at line 15. At line 16, we're going to say turtle.go-to. We're going to go to the x-axis in this direction of -150. And then we're going to go up 200. And then we'll put the pin down. And then after you do the pin down at line 17, it moves the pin down or place it on the window so that the drawing takes place. Let's take a look at that and see if that actually happens. I'm predicting that the design will look something similar to that on the screen. So let's run the program. Let's see what it's going to look like. So it will look very similar to what I showed on the screen. It moved it over vertically 200 and horizontally a -150. So it moved it closer to the quadrant to the left of this Cartesian coordinate. Hopefully this gives you a sense of how you're able to move your designs around and locate them in different quadrants on your screen. When you look at your overall screen, it might look a little bit more accurate here, but I'm sharing different windows, etc., so it may be a little offset. But this is a little bit more of what it's going to look like, but it did move it in comparison to the way it was originally. Notice that you have to pick up your pen, specify where you want your object to go, and then pin down, and then proceed to create the object or for the object to be drawn. So be very careful that you understand the order of the directions. It's linear at this point. So again, we use pin up, or you can just say up, knowing that it's the pin that you're moving up, and you can say down, and it's going to do the same thing. Let's run it real quick to make sure that works okay. Unless something is spelled wrong, it should be okay. Okay. Stay tuned for the next video.